Rocks and weathering. What breaks down rocks? Even the hardest rocks wear down over time, on Earth or on Mars. Natural processes break down rocks and carry the pieces away. How do scientists know what processes shaped Earth in the past? Geologists make inferences based on the principle of uniformitarianism. Oh my goodness. This principle states that the geological process that operate today also operated in the past. Scientists can infer that ancient landforms and features formed through the same process they observe today. Erosion and weathering. Erosion is the process of wearing down and carrying away rocks. Erosion includes the breaking of rocks into smaller pieces. It also involves the removal of rock particles by wind, water, ice, or gravity. Weathering is a process that breaks down rocks and other substances. Heat, cold, water, ice, and gas are all contribute to weathering. The forces that wear down mountains, like those in Figure 1, also cause bicycles to rust, paint to peel, and sidewalks to crack. Erosion works continuously to weather and carry away rocks at Earth's surface. What causes weathering? If you hit a rock with a hammer, the rock may break into pieces. Some forces of weathering break rock into pieces, as a hammer does. The type of weathering in which rock is physically broken into smaller pieces is called mechanical weathering. A second type of weathering, called chemical weathering, also breaks down rock. Chemical weathering is the process that breaks down rock through chemical changes. Mechanical weathering, if you have seen rocks that are cracked or split into layers, then you have seen rocks that have undergone mechanical weathering. Mechanical weathering usually works slowly, but over very long periods of time, it does more than wear down rocks. Mechanical weathering, as part of erosion, eventually wears away whole mountains. Animal action, so animals that burrow in the ground, including moles, gophers, prairie dogs, and some insects, they loosen and break apart the rock in the soil. Number 2, freezing and thawing. When water freezes in a crack, in a rock, it expands and it makes the crack bigger. The process of frost wedging also widens cracks in sidewalks and causes potholes in streets. We know about that in Michigan. Plant growth. Plant roots enter cracks in rocks. As roots grow, they force the cracks apart. Over time, the roots of even small plants can pry apart cracked rocks. Number 4, a release of pressure. As erosion removes material from the surface of a massive rock, pressure on the rock is reduced. This release of pressure causes the outside of the rock to crack and flake off like layers of an onion. Abrasion is what I think of when we say sandpaper or nail filing. Sand and other rock particles that are carried by wind, water, or ice can wear away exposed rock surfaces like sandpaper on wood. I think of the hot desert with blowing sand. Page 183. Agents of mechanical weathering. If you would like to take these numbers on this page and put them with the matching one on that page, you can do that at home. Agents of mechanical weathering. The natural agents of mechanical weathering include freezing, thawing, release of pressure, plant growth, actions of animals, and abrasion. Abrasion refers to the wearing away of rocks by rock particles carried by water, ice, wind, or gravity. Human activities such as mining and farming can also cause weathering. In cool climates, the most important agent of mechanical weathering is the freezing and thawing of water. Water seeps into rocks, cracks in rocks, and freezes there, expanding as it freezes. The ice then forces the rock apart. Wedges of ice and rock widen and deepen cracks. The process is called frost wedging. When the ice melts, water seeps deeper into the cracks. When repeated freezing and thawing, the crack slowly expands until pieces of rock break off. 2 little pages left. Chemical weathering can produce new materials. as it breaks down rock. For example, granite is made up of several minerals, including feldspar. As a result of chemical weathering, the feldspar eventually changes to clay. Chemical and mechanical weathering often work together. Chemical weathering creates holes or soft spots in rock, so the rock breaks apart more easily. As rocks break into pieces, more surface area is exposed to chemical weathering. Agents of chemical weathering. The agents of chemical weathering include water, oxygen, carbon dioxide, living organisms, and acid rain. Water weathers some rock by dissolving it. Water also carries other substances that dissolve or break down rock, including oxygen, carbon dioxide, and other chemicals. The other components are oxygen, carbon dioxide, living organisms, and acid rain. The oxygen gas in the air is an important cause of chemical weathering. Iron combines with oxygen in the presence of water in a process called oxidation. The product of iron oxidation is rust. Rust makes rock soft and crumbly and gives it a red-brown color. Carbon dioxide, another gas found in air. Carbon dioxide also causes chemical weathering when it dissolves in water. The result is a weak acid called carbonic acid. Carbonic acid easily weathers some kinds of rocks, such as marble and limestone. Living organisms. As a plant's roots grow, they produce weak acids that slowly dissolve rock around the roots. Lichens, plant-like organisms that grow on rocks, also produce weak acids. And then you have acid rain. Rain water is naturally slightly acidic. Burning coal, oil, and gas for energy can pollute the air with sulfur, carbon, and nitrogen compounds. These compounds react with water vapor in clouds, making acids that are stronger than normal rainwater. These acids mix with raindrops and fall as acid rain. Acid rain causes very rapid chemical weathering in rocks. How fast does weathering occur? Visitors in New England's historic cemeteries noticed that a surprising fact. Slate tombstones carved in the 1700s are less weathered and easier to read than marble gravestones from the 1800s. Why is this so? Some kinds of rock weather more rapidly than others. The most important factor that determines the rate of which weathering occurs is the type of rock and climate. Type of rock. The minerals that make up rock determine how fast it weathers. Rocks that are made of minerals that do not dissolve easily will weather slowly. Rocks weather faster if they're made of minerals that do dissolve easily. Some rocks weather more easily because they are permeable. Think of a sponge. Permeable means that a material is full of tiny connected air spaces that allows water to seep in. The space increases the surface area of the rock. As water seeps through the spaces on the rock, it carries chemicals that dissolve the rock. And the water also removes material broken down by the weathering. Last page, climate. Climate refers to the average weather condition in an area. That's going to be on our final exam. Climate refers to the average weather conditions in an area. Both chemical and mechanical weathering occur faster in wet climates. Rainfall provides the water needed for chemical weathering as well as for freezing and thawing. Chemical reactions occur fastest at higher temperatures. That is why chemical weathering occurs more quickly where the climate is both hot and wet. Think of a rainforest. Human activities such as those that produce acid rain also increase the rate of weathering, like in California.